Okay, so this is the first question here, and it is 2015 paper 2 question 4. Okay, so this is a very typical exam question, probably something like you will get. So two circles S and C touch internally, they do, okay, at B as shown. The equation of the circle S, so the equation of the big circle here, is this thing here, and the first thing they want us to do is write down the coordinates of the center of S. Okay, so the center of S needs to be 1 minus 6. That is what the center needs to be. And write down the radius of S in the form a root 10. Okay, so this is in the format this here. So this 360 represents r squared. So r on its own must represent the square root of 360. And if you put that into the calculator, you're going to get 6 root 10. Okay, so and I might put that into our diagram now. So we know that the center of the circle is 1 minus 6, and we also know that the radius of the circle here is 6 root 10. Okay, so that's a good habit to always do. Any information that you get, always put it into the diagram. Okay, so moving on to part B now. The point K is the center of circle C. So if we look here, we have our circle C, and the point K does look like it's the center. The radius of C is 1/3 the radius of S. Okay, so it's 1/3. So the radius of C has to be 1/3 the radius of S. So doesn't that mean then that the radius of C, if it's going to be 1/3 of this, wouldn't that be 2 root 10? Because 1/3, because that's 6 root 10, and 1/3 of that then would be 2 root 10. So we know that the radius of that small circle is 2 root 10. The coordinates of B are 7, 12. So I'm going to put that there. 7, 12. Find the coordinates of K. So we need to find the center of that circle. Okay, so to do this one, what I might just do over here is draw another little diagram, okay? So in a straight line here, okay? Down here, I'm going to put the center of S, which was 1 minus 6. And up here, at this point, I'm going to put B, which is 7, 12. And then if we look, and then here on the same line, we have K, and we are looking for K. All right, so to find K, if we think about it, they already told us that the radius of circle C is 1/3, so that this full distance here is 6 root 10, and this distance here, the radius of circle C, is 1/3 of that, which is 2 root 10. So right, it actually makes sense that this is split up into the ratio of 2 is to 1. All right, because this is a full 3/3. Right, the radius of the smaller circle is 1/3, so that has to be split up into the ratio of 2 is to 1. So now, this should look familiar now, because we want to split up a line in a ratio of 2 is to 1, and we want the point that splits it up. So that is a formula that we did in class. So that formula is bx1 plus ax2 all over b plus a, comma by1 plus ay2 all over b plus a. So this is the formula, it's in the log tables, and if you know the ratio, it will split a line up and give you the point that splits it up into that ratio. Okay, so how are we going to fill in all this? So the points that we're splitting up is 1 minus 6, and then the other point is 7, 12. And then the ratio that we want to split up in is 2 is to 1. So, like normal, this will obviously be called x1, y1. This will be called x2, y2. And this is our ratio A is to B. Okay, so now we just need to fill all of this in. So B is 1 by x1, which is also 1, plus A, which is 2, by x2, which is 7, and that's all over b plus a, which is going to be 3, comma b, which is going to be 1 by y1, which is going to be minus 6, plus a, which is going to be 2 by y2, which is going to be 12, and once again that's all over b plus a, which is going to be 3. Now, just to save a bit of time and a bit of space, I already have the answers done out to this. So the final answer there is the 0.56. So that there is the 0.56. So if you want to split this line up into the ratio of 2:1, okay, your answer is going to be 5/6. So that means our center of circle C is going to have to be 5/6. Okay, so our center of circle C there is 5/6. Okay, so next question then. Find the equation of C. So once again, I would like you to always do this. Every time you're asked to find the equation, all right, what two things you need? You need the radius and you need the center. Okay, this is of circle C now. We do know the radius and we do know the center. All right, so equation is always in the form x minus h squared plus y minus k squared is equal to r squared. Okay, we know the center hk is going to be 5/6. So that's x minus 5 squared plus y minus k squared is equal to the radius squared, and remember the radius was 2√10 squared, and then all you have to do is just put that into the calculator and that gives you 40. So the equation of circle C is x minus 5 squared plus y minus, sorry, that's supposed to be a 6. Sorry, it was a 6, is equal to 2√10 squared, which does turn into a 40. Okay, so that was that bit there. So once again, this formula, which comes up in coordinate geometry of the line, okay, can make an appearance in coordinate geometry of the circle. And you would use it when you want to get a line. You know it's being split up into a certain ratio, okay, and you want to find the point that splits it up into that ratio. Okay. The next one here, question C, was hopefully a little bit easier. Okay, find the equation of the common tangent at B. So the common tangent is a tangent to the big circle and to the small circle, and it would look, if I was to try and draw it in here, it would look something like that there. Okay, it is a tangent. Okay, and a tangent is a line. So we want to find the equation of a tangent, which is a line. So to find the equation of a line, what are the two things we need? We need a point on the line, and we also need the slope of the line. So let's look back at our line here. Okay, so we do have a point on the line. That's absolutely fine. The point is 712, but at the minute now we don't have the slope of this line going down here. So hopefully it is obvious to find the slope, because obviously this here is my radius. And what is the connection between a radius and a tangent? They are always at a 90-degree angle. So if I can find the slope of this line, all right, then I need to turn it upside down and change the sign, and that will give me the slope of that line. So just to save time, I'm not going to do it out. So the slope of this line, okay, you can use the points 1, -6 and 5, 6, or you could use the points 1, -6 and 7, 12. They're all in the same line. So the slope of that line works out to be 3. So therefore, the slope of our tangent is obviously going to be worked out at -1/3. Okay. So now you're in a position, now we know everything. Okay, so now we can go y minus y1 is equal to m bracket x minus x1. Okay, and the point we have to use is 7, 12, so it will be y minus 12 is equal to our slope is -1/3 by x minus 7. Okay, you would multiply all that out, okay, and your final answer then would be x plus 3y minus 29 is equal to 0, and that would give you your answer there. Okay, so this question here is 2013 paper 2 question 4, and again we're dealing with circles. They're touching externally as they tell us, and then we have a tangent coming down here. Okay, so the first thing anyway, the circles C1 and C2 touch externally as shown. Okay, and then they kind of give you a bit of space here without actually asking you any question. Okay, so we'll just move on to the question here, which is question A. Okay, so they say complete the following table. So in the table here we have circle C1. Okay, so that's the smaller circle. They tell us what the center is. So the center is -3, -2. So I might just put that into the diagram. -3, -2. And then the radius is 2. So I'll also put that into the diagram. And then, so now we want the equation. Okay, so if we have a circle, okay, so once again, I'm going to use this formula here. X minus h to be squared plus y minus k to be squared is equal to r squared. So it would be x plus 3 squared plus y plus 2 squared is equal to the radius squared. The radius is 2, so that would be 4. Okay, so there is the equation there. Okay, C2 then, all right, they don't give us the center and they don't give us the radius, but they do give us the equation up here. So from this equation here, we need to write down what the center is and we need to write down what the radius is. The center is going to be easy. The center is half of this number and change the sign, so that's going to be 1, and half this number and change the sign, so that's going to be 1. Okay, but to get the radius, okay, we need to use this space up here, because when the circle is in this format here, the only way of getting the radius is to use this formula, g squared plus f squared minus c. Okay, so that will be the square root. So g and f is the center, so that will be 1 squared plus 1 squared plus 7. So that will be 7. So that will be the square root of 9, which is equal to 3. Okay, so the radius of that circle there is equal to 3. Okay, so I'm just going to put all that information into the diagram. So the center there is 1, 1, and the radius is 3 of that circle there. Okay, so that was all you had to do for part A. Part B, find the coordinates of the point of contact of C1 and C2. So the point of contact would be right there. Okay, that would be the point of contact between C1 and C2. So to do this, I'm just going to draw another diagram down here. Okay, so this here is the straight line. All right, and it's between the center of C1 and the center of C2. So down here, I'm going to have -3, -2. It's going to go down there. And up here, I'm going to put in the center of the bigger circle, which is 1, 1. Okay, and then the point of contact will be somewhere maybe around here. That will be the point of contact. Okay, but we also know that the radius of the smaller circle is 2 and the radius of the bigger circle is 3. So that's 2 and that's 3. So that means that this line here is split up into the ratio of 2:3, and we're looking for the point that splits it up into that ratio. So just like in the last question, now once again we are going with this formula here, bx1 plus ax2 all over b plus a, and then by1 plus ay2 all over b plus a. And this is a formula for splitting a line segment up into a certain ratio. Okay, so when you're filling in this diagram here, obviously the 2 points are going to be -3, -2, and the other point is going to be 1, 1, and the ratio is going to be 2:3. So to label this then, that's going to be your x1, y1, x2, y2, and this is going to be your a:b. So now you know what everything is, and you would fill it all in to this formula here, just like I did in the last question. Okay, and the answer that you get out is going to be the point -7/5 -4/5. So that is going to be the point here. So it's going to be -7/5 -4/5. So that is that point there. So that means, so the point here of contact is going to be -7/5 -4/5. So that is our point of contact there. So once again, this formula here is coming into this chapter where we know the ratio, okay, and we want to find the point that splits it up. Okay, and then finally then, hence or otherwise, find the equation of the tangent t. So we want to find the equation of this tangent, okay? And once again, this is a line. So what are the two things we need to find the equation of a line? You need the point and you need the slope, and then you're more than likely going to be using this formula here. X minus x1. Okay, so we do have a point on the line, on our line t here. Okay, it is the point of contact, so it's minus 7 over 5 minus 4 over 5. That's our point, but at the minute we don't have the slope. But I'm hoping now we could figure it out, because we could get the slope of this line here, all right, and then we do know the slope then of the tangent because they would be perpendicular. So just to speed things up, if we do get the slope of this line here, okay, so of the line of our two centers, all right, we get an answer of 3 over 4, which means the slope of our tangent will need to be minus 4 over 3, okay, because they're perpendicular. Okay, so now we have everything. All right, we have a point and we do have the slope. So now I can fill in this formula here. So it's going to be y minus y1, which is going to go to plus 4 over 5 is equal to our slope, which is minus 4 over 3, by x plus the x value there, which is 7 over 5. Okay, so a lot of fractions here. What I would probably do here is I'd go y plus 4 over 5 is equal to minus 4x all over 3 minus 28. Okay, so top by top is 28, bottom by bottom 3 times 5 is 15. Okay, and then finally then all you have to do is multiply this whole thing then by 15, okay, and that would give you your final answer. All right, so I'll just write down the final answer that you get then. It is 4x plus 3y plus 8 is equal to 0, and that is your final answer.